Hi guys, I'm in the staff room today and I'm going to be showing you how to make agar plates for culturing bacteria. First of all though, why might you want to do this? This I think is actually a really versatile procedure that can tie into loads of different outcomes, and I've used it several times. So anything to do with biodiversity, when you want to investigate the microorganisms in a particular environment, you can do that there, and of course you could make that more experimental by comparing the microorganisms in a classroom compared to the microorganisms in the playground versus a woodland, and do a direct comparison between all of them. You can use it for any outcomes to do with perhaps water purification. There's some outcomes to do with that, so you can do it, culture the bacteria from tap water, water from a puddle, and water that's straight out of the kettle, and compare what sort of bacteria you get growing from each of them. You could also just do it to do with anything to do with germs and hygiene, even tie it into health and well-being. So to do with hand washing, compare the bacteria growing on hands that have been just washed recently with antibacterial soap, maybe antibacterial hand gel, versus just water versus no hand washing at all, and see what bacteria grows there. So the best thing to do, I think, is always to try and make it experimental, and to try to get the kids thinking about what variables they can introduce. Remember that the essence of experiment is comparison, so they need to think about what they can be comparing and how to make it a fair comparison. But as long as you're doing a fair comparison, you're doing an experiment. So the procedure for actually making it, we're going to make 1 litre of agar, which usually is enough for about 25 plates of this sort of size. So you'll easily get one between two. Most kids would be able to get one each. So you can share that around your class as you see fit. The recipe for 1 litre is you're going to need obviously 1 litre of water. You have 20 grams of bovril, 15 grams of agar, which can just be bought online. Loads of different distributors for that, really easy to get hold of, and 5 grams of salt. And that's all we're going to be using. Now, to start off with, we want to be working with warm water for this, certainly ideally hot water. If you can get it right out of the kettle, that's perfect. So I'm going to start off with just 100 millilitres. 100 millilitres to start with. Fairly roughly, we don't need to be super accurate here, so I've gone a bit over 100, that doesn't matter. And all I'm going to do, get all our tubs out of the way, I'm going to combine all the ingredients together. So in goes the salt, in goes the bovril. This is always the harder task, and I might need to top this up. Now the reason for the bovril, I'm going to stand up so I'll probably be out of shot, I apologise. The bovril is what gives it the nutrients that it needs. So the bovril is the main ingredient that is providing the food for the microorganisms to live on. That'll start to dissolve in time. I'm going to scoop a wee bit more out here. That spoon will probably start to get hot. Now I put slightly more than the necessary amount in there because I knew that there would be some residue left behind. Hopefully we've managed to get most of that off. This is always the fiddly bit though. So I'm working fairly fast. I'm not going for a perfect procedure here. Obviously you can take a little bit more time when you're doing it yourself. I'm going to mix that in. And then I'm going to add in the agar. Now the agar is just a thickening agent. There's nothing really that special. I want to be adding it and stirring it in as I go, so that it gets time to dissolve. But this is going to start to create a slightly thicker consistency, and almost like a bit of a paste. And just keep stirring, mix it in, and you'll feel that thickening fairly quickly. Now, the quantities I gave are fine for 1 litre. So again, 5 grams salt, 15 grams agar, 20 grams bovril. If you add slightly more agar, that's fine. It just means you're going to have slightly more solid plates. And that's not a problem. The bacteria will grow in it. What I would say is don't add too little. Otherwise you get really runny plates, and that's just no good. Now, what we're going to do next is we're going to start to top it up, stirring all the time as we go, up to the litre mark. Now, I will say you're not going to get to see the full procedure today because I would normally need to let these cool, and then obviously I would culture the bacteria from wherever I'm wanting to culture them from. And for the scope of a 5-minute video, I've just not got the time to do that. But you'll get an idea of the overall procedure. So I have here a thickish solution. It's still fairly watery, but as it cools, that will thicken up nicely, and all I need to do is pour it into the plates. However, at the moment, the temperature here is high, but it's probably not high enough to be completely sterile. Now, we're working in the classroom. We're not real scientists. We're just doing the best we can with the tools that we have. And I think the best that we can is still fairly good for a classroom setting. But what I would do to try and make this a little bit more sterile, first of all, if I was doing this for real and I really wanted my kids to experience this to its fullest, I wouldn't have an exposed plate right from the start. So my plate would be ideally a new plate, completely sterile, with the lid on it, and the lid wouldn't come off until I was ready to pour the agar. What I would also do once this was, once I'd measured it out, I would transfer it to a microwavable container and I would heat it up to boiling point. So once I see it bubbling, I know that that'll be hot enough, and at that point it's going to be sterile, and I can then start pouring it into the plates. Now, to pour it into the plates, what you would do, I would have a lid for the plate. I'd remove the lid, and we're just filling it to about half full here. So pouring it delicately, filling it to about half full, and replacing the lid. Now you will get some condensation. Once I had all my plates full, and like I said, I'll get about 25 out of this, I put them in the fridge until they cool off. Once they're cool, they're ready to be used. So you want to explain to the kids how they're going to use it. It's very important that they're keeping it as sterile as possible, because even bacteria in the air will be able to grow on this stuff. So you would explain to them they need to use a clean swab, a sterile swab, and yeah, I just use cotton buds. Is it completely sterile? No, but it's good enough for our purposes. They're just getting the experience of using this. So you use a cotton bud, they swab whatever they're wanting to swab, whichever environment they're wanting to compare. You can even quarter the plate and have a different section of the plate for each environment. They swab their substrate, and then they're going to open the plate only enough to insert the cotton bud and inoculate that particular area. So I would demonstrate this to the kids, show them that you're only opening it at just a tiny amount so that there's minimal air getting in there. You rub the swab onto the area of the plate that you're wanting it to grow on, and then replace it. Once you have completed taking your sample, these are sealed with sellotape, so you just tape around it, and they are then not opened by the kids again. This is really important because you can't absolutely guarantee the safety of what you're going to be growing. There is a high chance of you growing things like E. coli in fairly high quantities. You'll be growing some fungi as well, and all of these do have inherent risks as part of them. As long as you keep the plate sealed though, the risk is minimal and it's fine to use. I would also get my kids wearing gloves when it actually comes time to handle them, and they should wash their hands after handling them. So the plates will get sealed, they'll be left for about a week. When they want to look at them, they glove up and they get to look at them. They shouldn't hold them above their head too much, just in case there's any condensation that drips out. They should be able to look at the plates quite easily. They'll be able to see what's grown on it. You could get them to sketch that, do some scientific drawing based around it. Loads of different follow-up activities that you can do. You're a teacher, you can come up with some decent tasks to follow on with that. But the kids must not open them. If you want, you could do some identifying of the different microbes that you've grown based on the size of the colonies, the shape of the colonies, the colour of the colonies, the texture of the colonies, whether they're shiny, whether they're fluffy. These are all identifying factors. In terms of safe disposal, a good enough strategy, and it's the strategy I use and it works fine, is just to use a large basin and fill it with boiling water. So straight out of the kettle, get it nice and full, and add a generous quantity of bleach to that. Once that's done, I would just cut each of the bits of tape and submerge each of the plates directly into that and leave it for at least half an hour. You'll find that most of the colonies, most of the bacterial colonies will blacken, at which point, and some of them might even float to the top, but they're dead, they're dealt with. Once that's done, you can dispose of all the bleach down the sink, and any agar that's still remaining, I would tip that into a plastic bag, double bag it, and it can just go in the bin at that point. That is a reasonable way of getting rid of it, and there's minimal risk involved in that. You definitely need to do a thorough risk assessment for any of these experiments, but I think the benefits of it far outweigh the costs, and it's such a good experience for the kids. And this, because it's so versatile and takes so many outcomes, I think all teachers should know how to do this because it's a great experience. So please give it a shot. Cheers.